Practical 23, Determination of Chemical Oxygen Demand in Wastewater. Chemical oxygen demand (COD) analysis is a measurement of the oxygen depletion capacity of a water sample contaminated with organic waste matter. Specifically, it measures the equivalent amount of oxygen required to chemically oxidize organic compound in water. The COD is often measured using a strong oxidant like potassium dichromate, potassium iodide, and potassium permanganate under acidic condition. A known excess amount of the oxidant is added to the sample. When oxidation is complete, the concentration of organics is the sample calculated by measuring the amount of oxygen remaining in the solution. This is usually done by titration using an indicator solution. COD is expressed in milligram per liter, which indicates the mass of oxygen consumed per liter of solution. The major advantage of COD test is the short time required for evaluation. The determination can be made in about 3 hours rather than the usual 5 days required for the measurement of biochemical oxygen demand, which is BOD. Next, the procedure. Wash culture tubes and caps with 20% of sulfuric acid before using to prevent contamination. Place sample in culture tube or ampoule and add digestion solution. Carefully run sulfuric acid reagent down inside of vessel so an acid layer is formed under the sample digestion solution layer, and tightly cap tubes or seal ampoules and invert it several times to mix completely. Third, place tubes or ampoules in block digester preheated to 150 degrees Celsius and reflux for 2 hours behind a protective shield. Cool to room temperature and place vessels in test tube rack. Some mercuric sulfate may precipitate out, but this will not affect the analysis. Remove culture tube caps and add small covered magnetic stirring bar. If ampoules are used, transfer content to a larger container for titrating. Add 0.05 to 0.10 milliliter, equivalent to 1 to 2 drops of ferroin indicator, and stir rapidly on magnetic stirrer while titrating with standardized 0.1 molar of ferrous ammonium sulfate titrant. The endpoint is a sharp color change from blue-green to reddish-brown, although the blue-green may reappear within minutes. Next, the scientific review. This review based on two videos. The two video. This about conventional digestion method and reaction digestion method. From the video, we know that BOD is measures the biodegradable organic matter, while COD is measure all organic matter, whether biodegradable or non-biodegradable. In this case, the COD values of water sample can be typically related to its BOD value in more or less constant ratio. COD value are greater than BOD value. COD measurement can be made in few hours, but BOD measurement takes at least 5 days. The spectrometric method consists of adding strong oxidizing potassium dichromate to the water sample under acidic condition, sulfuric acid, and using silver as a catalyst. The Beer-Lambert law affirms that for some substance, light attenuation or absorbance is proportional to the concentration attenuating species in the water sample. The darker the orange color, the greater the COD value. Therefore, the larger the organic matter in the water sample. If the water sample turns green, means the COD value is out of the range.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Ainulnisa binti Nasri. My metric number is A174661. So today I'm going to present about the Practical 23. The title is Determination of Chemical Oxygen Demand in Wastewater. But our group will able to find the COD and BOD data. So actually my part is data analysis. So I'm going to continue after my friends. So thank you Hazreen. So I'm going to continue. So the first thing is, I'm going to show the tables of data for COD. So as you can see here, is actually COD. So COD, the unit is actually mg over liter. It could be ppm, but here I'm using mg per liter. So as you can see here, the trend of the data is actually quite the same. As you can see at the sample T1, T2, and T5 showing the same value. So at T3 and T4 and T6 showing the same value. So what you can see that it's showing the same trend. So what is actually the T1, T2, T3, T4, T5 and T6 is actually the sample location. So here I'm adding the information about the T1, T2, T3, T4, T5 and T6. So basically we conduct this experiment at the Kalibaru village, which we testing the water at the Kipagar River. Kipagar River at Kalibaru village. Okay, so I'm going to continue, which I'm going to show how we take the samples. So the first thing is, as you can see, the sample 1 is actually being taken at the upstream before entering the Kalibaru village. So I'm going to allocate, this is Kalibaru village. So here the river here and here. Okay, so this is Kalibaru village. So for sample T1 is actually taken upstream before entering Kalibaru village. So possibly it could be here. This is actually sambungan lah. Okay, so then T1, and then T2 is a place of the river water utilization for MCK. So utilization maybe is possibly to be here. And T3 is a place that have been potential to be contaminated due to the activities of batik waste and domestic waste. How can it's actually having the domestic waste? It's actually because around the factory, around the batik factory, there is a villagers staying there. So the villagers could basically defecate or throwing waste into the water river. So when it's happened, it's polluting the river. So this is actually T3. So T4, as you can see here, so T4 is actually downstream after. The word here is after batik waste disposal activities and domestic waste. So as you know, this happened here. So after going through and downstream, so that you could possibly T4 here. Alright. So T5 is the meeting place of two rivers, location entry of the creek. So T5 could be here, where this the river, water 1, water 2. So it meet here. So T5 is here, T4 here, T3 here, T2 here, T1 here. And T6 is actually downstream after the Kalibaru village. So it could be far away after you go through here. So maybe it's possibly T6 here. So we got T1, 2, 3, 4, 5 and 6. So here how it been done to take the sampling location. So next I'm going to continue about the BOD, which is biologically oxygen demand. So actually the different, so as you can see here, there are no trends in the BOD values, because you can see it's higher and then go down, and it's going back higher and decrease and increase and increase. Why is actually this happen? So I'm going to explain it later. So okay, now let's continue to the calculation. So actually the calculation is about the data analysis process, which is a statistical data analysis used for pollution index calculation. So in COD, we can from the data we can get the minimum and the maximum yield of the data. So the minimum is 118.8, which we can get from the table, this one and this one, and 138.6 is the maximum, because as you can see, the trend in the COD is actually only have 2, which is 118.8 or 138.6. Okay, so we can also get the average yield. Average yield is actually the mean of the data. So what is actually mean is so important, because the mean used to represent the set of data. If the x bar is greater than standard deviation, so this the value of the mean can be used to represent the set of data. But if x bar is slightly or less than standard deviation you calculate from the data, therefore the x bar cannot be used to represent the data. So it's actually not good. So you have to calculate the standard deviation. Either you can know whether the average yield is actually good to be represented as a group of data or not. So from the data, we just using the formula, standard deviation is x minus x bar squared over n minus 1. So as you can see here, 118.8 minus 128.7, which is the average yield. Squares, and you totals everything and divide by 6 minus 1, and you can get 10.22468. So as you can see in the result, the value of the mean for COD is 128.7. 128.7 is actually greater than 10.22468. Therefore, the average yield can be used to represent the sets of data. Okay. So next, moving on to the biological oxygen demand, BOD. Okay. So let's continue. It's actually the same thing, but we can see that the range value for chemical COD is actually bigger than the BOD. BOD is only showing less than 1 mg per liter, or as you can see here, the value is smaller compared to the COD. So the first thing you can see here, the minimum yield for BOD is 0.13 milligram per liter, because in this data you're not using this one or this one, using this one. To get the BOD is actually, there is a formula, but I can't remember the formula. I'm going to show you later. So BOD, as I calculated here, so you can see the smallest value is 0.13. So the maximum yield is 1.17 milligram per liter. This is milligram per liter. Okay, this the unit. Okay, to calculate the average yield, we know it's actually as a mean. Mean is using the formula sum of x over n. So you can get the value of the average yield. So as you can see here, I'm sorry, it's actually having this value, but it's not, it's being cutting out from the picture. So the value is actually 0.38364. Okay, so as you can see here, this, you compare this, so the average yield is 0.5617 is actually greater than 0.38364. Therefore, the X average yields can be used to represent the sets of the data. So in your experiment, you can use this value to indicate the value of the overall data. So now we're moving on to the tables of BOD and COD. Okay, now so we continue. As you can see here, the table 3 is the parameter we use is BOD and COD. As we know, BOD and COD is actually biological oxygen demand, while COD is actually chemical oxygen demand. Okay, so oh my god, sorry. So what is the difference of BOD and COD? So the meaning itself gives it the difference, which BOD is actually the measurement for biodegradable organics, while COD is for measures biodegradable and non-biodegradable organics. BOD using oxidizing microorganism, while COD only use strong chemical agent. So see the difference? And BOD could be affected by the toxic substance because it kills the microorganisms. Okay, and COD are not affected by the toxics and temperature. BOD can be affected by the temperature. I'm going to explain why is this happen now next. Because if the river contaminated by the organic matters, the microorganisms in the water will act to oxidize the organic matter, and if there is a toxics in the layer of the water, it could damage and kill the microorganism and affect the process of the BOD to happen. Okay, if microorganism low, the BOD will be low. Okay, next I'm going to explain. In COD testing, the COD results were almost the same like what I said earlier, because like at point 1, 2 and 5 you can see like 11.8, and at point 3, 4, 6 1.38.6. The COD value obtained from the test result, because the number of chemical compound can be oxidized chemical is greater than the biological. Because as you can see here, the difference is very huge, because like this is 100 somethings, but this one is only like not reach 1, and the highest one is only 1.17. So it's showing the biggest range difference. Why it's actually happened? Because COD reaction gone through fast reaction, it fast, so the value of the COD can be calculated is actually bigger. In BOD testing, the highest BOD result is at the 3.3. Why I'm saying at the point 3? Because point 3 is actually where the batik waste and domestic waste happen. Okay, so at here domestic waste is bigger. So when it's bigger, there is more organic matters in there. So it could be that the disposal waste is higher, so microorganism works higher and BOD going to be higher at that place. And the lowest BOD showing at the 0.4, because we know that 0.4 is actually where the disposal happen. The disposal of the everything like the toxics from the factory, batik factory, happen here. So it could be toxics. It could be that what we called it, phenol, caroline, detergent, cinnamide acid, insecticides that can kill or can cause the microorganism in the water to die, and the number of the microorganism becomes small. So the oxygen needed by the microorganism is also small, showing that the BOD going to be decreased and getting smaller. That is why at the T4 is actually it have the lowest value of the BOD. So as in the COD, why we get that there is a place where I get high here and lower? Because at the T1 COD, I'm going to erase this. At the T1, the water samples are not affected, so the value will be low because there's no pollution, or there are just low pollution happening there. It could be only because of the domestic. Okay, at the T2, because it's getting the same, so I'm not near again to the T2 3, so the value is actually not have any difference. So at the T3, we know that the value located potentially contaminated area, at the contaminated area, and it have the pollution of the batik waste, factory, the domestic waste, and it's a lot happening here. So therefore the value is actually higher, because COD is we used to the calculate with the it's not like calculate, we see whether the place is actually polluted or not. So at the T5, why is actually it's from T4 to T5 it's decreased, because it's decreased because, as I said, the T5 is actually where the place of the two rivers connect or meet. So when there is pollution here and non-pollution water here meet here, it's going to be the concentration of the pollute would be decreased as the purified water makes its volume, because like you can see here, unpolluted water coming and combine here, it's meeting here, so the value is actually lower compared to this one, because this one going to be higher compared to this one. Okay, I'm sorry, this is going to be lower than this one. Okay, alright, so that is why the value is decreasing. So I think this is all from me, so thank you.